Hello, this is in continuation with introduction to machine learning that we started in the previous session. So we will continue to understand more on machine learning. So here we will have the basic definition of machine learning, and we will also see the concept of task, experience and performance. So now let's go for the formal definition of machine learning, which is given by Professor Mitchell. A computer program is said to learn from experience E with respect to some class of task T and performance measure P. If its performance at task T as measured by P improves with experience. So this is a formal definition for machine learning which has been provided. So here we are having three terms. The significance is given to three terms. The three terms are task T, performance P and experience E. So let's try to understand these three concepts better. But before we move ahead, this is very simple. We can understand it with an example. Whenever you are doing some task, whenever you are learning something new, right? So what you do is so first of all, the thing is, what are you going to do? What is your objective? So that is your task T. Means the task that you are going to perform is your objective or the problem that we are going to consider. So when you start doing that task, whatever input you are getting and based on that you perform that task, then you start learning that. That is considered as the experience. And finally, when you perform that task, whether you are able to perform it successfully or there was some problem, there was some error, that will determine the performance. So gradually the objective is the performance should improve. The model should be designed in such a way that performance should keep on improving. So that is the idea behind machine learning. So let's repeat the definition one more time. A computer program is said to learn from experience. That means we have developed a program which is learning. So how it is learning? Already we have given some input, and based on that input it is now trying to predict the output. So that output is again acting as an input to the machine. So that is its experience. And it is doing this with respect to some task. This program was written with some objective in mind. That was the task it was performing. And finally, it is predicting some output. It is giving us some output that will determine the performance. So that is the performance of the particular machine. So here we have these three terms that we need to understand. So ML is the field of artificial intelligence, consists of learning algorithm that at executing some task T. So we are executing some task T over time with experience E. So gradually the machine is gaining experience and improve their performance. So eventually the machine has to improve the performance. So based on this, we have the diagram where we have the task, we have the experience, and finally we get the performance. So what is a task? From the perspective of problem, we may define a task T as the real world problem to be solved. The problem can be anything like finding the best housing price in the specific location or to find the best marketing strategy. So it is again a very common task that we might have to predict what will be the house in the price of the house in a specific area, or what could be the rent in this area. So for that we are going to give some input to the machine, and the machine is going to predict or tell us what could be the specific rent or the price of the house. That is the task or that is the problem that we are currently experiencing. Another example can be we have to predict the salary of the employee. Now how to do that? So the salary can be determined based on certain components like what is the experience of the person and what is his overall age and what are the skills he possesses. Based on that, when we put them together, we can determine the salary of the person. So these features, these input things are considered as features. So we have multiple features. Based on that, we are trying to predict the output that is considered as the target feature. So putting things together on the task can be, if we talk about machine learning, the definition of task is different because it is difficult to solve machine learning based tasks by conventional programming approach. So here the things we need to more formalize the definition of task, because the task, the way it is being solved in machine learning will be different. So the example of machine learning based tasks are classification, regression, structured annotation, clustering, transcription, etc. So the task can be put in different categories, or we can formalize it in different ways. Next comes the experience. As the name suggests, it is the knowledge gained from data points provided to the algorithm or model. So, as I told you earlier also, we have a machine, we gave some input to the machine. Now, based on that input, the machine is trying to draw out some pattern, and then it is trying to develop some model. So, based on this overall activity, the machine is gaining some knowledge. So that knowledge which is it is gaining is termed as experience. Once provided with the data set, the model will run iteratively and will learn some inherent pattern. So there will be some pattern that the machine will determine. The learning thus acquired is called experience. So even we face the same thing, right? Initially we are beginners. So gradually we start learning, and then we become experienced. So whatever learning we have gained over this period of time, that is considered as our experience. Making an analogy with human learning, we can think of this situation as in which a human being is learning or gaining some experience from various attributes like situations, relationships, etc. So, based on, means we, as I said, in our day-to-day life, we are learning based on some particular situation. So that is the experience we are gaining. So we have different ways like supervised, unsupervised, and reinforcement learning. These are the different ways which we using which the machine will learn or gain experience. The experience gained by out machine learning model or algorithm will be used to solve the task T. So all this experience will ultimately target to solve the particular task T that we have seen in the previous slide. So here in the house prediction, price prediction, so whatever input we have given, so the machine is trying to gain the experience. If the house has two bedrooms, more than two bedrooms, if no, then it is comparing the size. Based on the size, it is predicting the particular price of the house. Similarly, if it has two or more bedrooms, then again it is checking for the size, and based on that it is predicting the price. So this is the knowledge that it has gained is termed as the experience. Finally, we come across performance. A machine learning algorithm is supposed to perform the task and gain experience with the passage of time. So as I said, we all learn something, and based on that we try to produce some output. So whether our output was up to the mark or not, that is the performance measure. So the measure which tells whether machine learning algorithm is performing as per expectation or not is its performance P. It is basically a quantitative metric that tells us how a model is performing a task T using its experience E. There are many metrics that help to understand the machine learning performance, such as accuracy score, F1 score, confusion matrix, precision, recall, sensitivity, etc. So, see, the idea here is when we have developed a machine, the idea was to perform a particular task. Okay, so if I go back to the house prediction algorithm, so we developed a model that should predict the house. So after when I gave him the input, he has given me, suppose this is the output which the machine has predicted. Now I will compare it with the real world scenario or real world data. If this matches closely with the real world data, I will say the machine's accuracy or the performance is very good. But if it is means there is lot of difference in the real world prediction, then I will say the machine is not good. So the performance is not very good. The machine needs to be reworked. We need to reanalyze and rework and redesign the algorithm. So that is how we need to understand the performance. So as we said, there are different ways to understand what should be the performance. So performance should be very close to, we can say, the accuracy has to be close to 100%. Obviously, it cannot be 100% because there will definitely be some errors and some parameters which will affect the accuracy, but it should be somewhere 80-90%. Then we will say, yes, it is a good accuracy. So let's summarize what we have seen. So we have understood the formal definition of machine learning, that a computer program is said to learn from experience. Whatever input it has received, based that will work as an experience, and its objective was to perform some task. So with respect to some task T and performance P. So it is giving the output, it is giving the prediction that is considered as its performance. So this will be actually the machine learning algorithm. The task T can be any real world problem to be solved using machine learning. Once we provide the data set, the model will run iteratively and will learn some inherent pattern. This learning thus acquired is called as experience. Finally, we measure whether machine learning algorithm is performing as per expectation or not. This is called its performance. So that's all for this session. Let's stop here. Thank you very much.